Welcome back, friends, to the new episode of Busting the Buzzword. Today, we are going to bust the buzzword of generative Gen AI or generative AI because this has become so common that people think generative AI, generative AI is equal to LLM. Some people even understand that ChatGPT is nothing but uh, ChatGPT, Gemini. So people equate generative AI to LLM, chat gpt and whatnot. Today we are going to understand this properly, and we will understand that generative AI is not equal to LLM and is not equal to chat gpt for sure. Meanwhile, we will also understand there is a different class of AI called discriminative AI and how they are different. So this is the agenda today. Let's get going. So friends, in machine learning, right, in machine learning and in general in the world, real world also, there is a two way where how people learn. One is by differentiating things, another is by properly understanding things, right? For example, let's say you take a child and you show him a dog and cat, 2 year baby. Maybe it's not able to understand dog and cat very properly, but by seeing some of the dog it will able to differentiate. So if let's say next time a dog comes, it will able to understand it's a dog, not a cat. So what is happening here is we are understanding that how to differentiate between the classes. Okay, that is the main focus here, and in our mind we create a mental model of the decision boundary which help us to separate these two classes. So and there are so many algorithm here. For example, all the classical machine learning, for example, logistic regression, decision tree, they all fall under this. Taking one more example, let's say you get an email like and spam, right? So if you give a lot of examples of ham and spam, so let's say this will have word called lottery, prize, win. These words are common here, right? If you give this good number of example of ham and sam to a discriminative model, what it will try to do is it will able to understand based upon how the distribution of spam words are. It will able to if your new email comes, it able to say whether it's a spam or ham. That's the only thing it will able to do. But let's say if you say, hey, can you create me a genuine email, new email, it will not able to do because it has not understand that if you let's say distribution of words in a spam, it has not understand the full distribution of this. So it once if you since it has not understand that full distribution, it will not able to give you or generate you the new spam or let's say new ham. Nothing it can do. And this is the job of a generative model. So when we call generative AI, basically we are talking about all those models which does this is it understand the full distribution of classes. Okay, and since it understands the whole distribution, when you ask it to generate a new sample of that class, it is able to give you because it understood the whole distribution. So definitely, right, understand, just able to like kind of, if you think from perspective, right, making just a distinction between dog and cat is easier than really understanding each and every feature of dog and then drawing a new image of dog. So that's why discriminative AI were actually were ruling the roost before we got breakthroughs in generative AI because it's much easier, even require less amount of data, because of the nature. In the real world, you can think of discriminative models like a bouncer, right? They don't know like every people who are coming there. They don't he don't have to understand. Basically, he has some criteria like check the ID and it will able to say whether it's a valid guest or maybe some gate crashes. That's the only job of bouncer, so doesn't require a lot of intelligence. But compare this generative model like a safe. Now safe cannot create a recipe. For example, it cannot create a let's say cake just by understanding how to difference between cake and patties. That will not be sufficient. It has to understand what each and every ingredient goes under the cake and how do we kind of cook the cake. So this is what the difference between, and this will be very handy while going forward, right? And this will help us avoid the misusing this word, at least generative AI. Now, friend, so there are multiple type of generative AI, and because we have got like accustomed with this word LLM so much, we think that LLMs are the only generative AI model available. But you might be surprised to know LLMs were not the first model, or like not the very famous one just some year before. So first model which got a lot of attention in generative AI is called GAN. GAN is Generative Adversarial Network. Now, generative we understand. So basically, it will able to generate things, right? What is this adversarial? Is that we'll come to know. And network because it's a deep learning network. So adversarial part will understand why we call why this word is used here. Now, what I have done is I have listed some keywords here that will be you that we you can just take it for face value now. Once we'll understand this model in depth, we will explain these all terms, right? Right now we are just kind of giving a very high overview so that tomorrow somebody uses this word, you know what does it actually mean. So gain network is consist of two partner in the crime. One is called generator and discriminator. So basically gain is the one where actually both kind of machine learning, discriminative discriminative versus and plus generative, both collaborate together to create something beautiful. Now, so what generator does, right? It's you can think it as a forger. Why we are talking as a forger? Because the only job of generator is to create a new sample each step. As each step, it creates a new sample. For example, let's say we are trying to imitate Mona Lisa, Mona Lisa photo. So it will create first very crude version of Mona Lisa first. Then what? Then it will just give this image to discriminator. Now discriminator, the only job for discriminator is it will understand and it has to classify it as a fake or real, right? It it just and because discriminator just learns to differentiate and it will able to mark it like no, this is fake image. Now what will happen is it will give a loss. So you might be aware of this vertical loss, right? Which is how machine learning model train each other. They will try to minimize the loss. So loss for generator and discriminator in this network will be different, and generator loss will be optimized when it able to kind of imitate Mona Lisa picture perfectly. So perfect imitation. So that is the goal of generator. And this guy discriminator will be loss will be minimized when it is able to differentiate the fake. So that's why this word adversarial, because actually they are competing with each other. This guy is trying to fake it, and this guy trying to catch it. So this network back and forth happens, and you might be surprised or maybe curious to know, right, how this will converge, because now it can keep generating more and more image, it will keep differentiating. So that's how, so just to make understand, right, this is generator. So you can think it as like artist, and this guy is a detective. So that's how these two network, trying to outsmart each other here. A lot of application, deep fakes, realistic images, faces. Now there is something called NAS equilibrium, which we'll talk about when we cover this in depth. This is where actually we say model actually converged. Now, what is this PG and P data? P data is the actual data. For example, actual Mona Lisa image, Mona Lisa image, right? And this PG is what is generator is kind of generating. Now, when these two distribution look starts to look similar, we say model converged. We will give some practical tips also, but this is what theoretically it means. Another thing is when discriminator is not able to make distinction, the images are so real that it's not able to kind of differentiate much for it. So probability of its kind of identifying a fake image becomes zero point 0.5. Basically it's like 50-50. So this is the situation where we say no, a model has converged. But practically this is like theoretical part. Practically what we do is we have some validation sets, okay, like any machine learning will have some validation sets, which data which is the separate from training and testing. So testing actually where we do the actual testing with the unknown data. Training is which is the data used for training. Now the third term is validation. Now in validation, what we do, we keep very small sample here also, so that we understand how well the training is going on. So basically, what happens is it's also called held out set. So when model stops improving this, we think, or we conclude that no, we cannot excuse much out of it, and hence we consider this training over and model converged. Now this might be most exciting slide for you, because this is where your LLMs are here. Now, if you see, right, we never, you might have not heard even what is autoregressive model. So in all the generative AI model, we understood there are multiple type like GAN, and we will learn some more. Now this is, so autoregressive model are another type of generative model. Now, how this model works is you give a sequence, and then you train model to predict the next word. Right now, you might be understanding. Okay, you might have heard, right. This is how LLM works. So, guys, LLM are nothing but a kind of generative AI model which is called autoregressive. So LLM basically you should stop calling generative AI. You should start telling no autoregressive generative AI Gen AI model. So this is how, so many of you will be aware this is how LLMs works. So you give a sequence of word, and then you ask it to train the model to predict the next one. So this is the way in which we kind of why it's called autoregressive is very much clear, because while predicting this, it actually regresses or depends upon what the word have already come up, right? So that's why it's called autoregressive. Now these are the word which we'll cover when we understand this autoregressive model. But one thing I want to explain is what is temperature, because this will be because people use it day in day out, right? People so temperature doesn't mean fever here. So low temperature and high temperature. So what happens is, now you given this three word, right? Now there is like big sample space from which it has to choose this time, right? So instead of time, it could choose something else. Once upon a time, or maybe it can say once upon a era, something like that, right? So what is the one factor here is how creative you want the generative AI autoregressive model to be. Now, if you make the temperature high, it will become very creative, okay, and wild. But if you want to create a kind of um, industry driven or output driven model, generative, we keep the temperature low, and no, because we want to be a little bit predictive. Now, what is the mathematical meaning of this temperature? We'll understand when we go through this model in the detail. So this model works for LLM, we understand that, but this can also work for the image, right, and the sound, because this is like very different, very proven pattern. Like let's say in the sound also, if you can train it to predict the next sound, right, what is next, then it can actually generate the audio also. That's why you see like a multi-mode we say, like LLMs are multi-mode, right? Not LLMs, generative AI are multi-mode. Let's say if it works only with the text, we call it LLM, but then it can also generate the images and sound, of course. So these are the popular GPT, Llama, Pixel, CNN. This is also for visual, and this we are very much no, this one we can just take for example. So when you say the, it gives you the cat. It's just example to show this. Now let's discuss about diffusion models. Again, this is again type of generative AI. What it does is it has two pass: forward pass and reverse pass. In forward pass, what it does, it takes a clean image, okay, takes a proper image, add different uh, static. You can think about different transformation. We will discuss this. What does it mean? So it adds multiple transformation till it generates a pure noise, right? Definition of pure noise is you cannot extract anything meaningful out of it. It does so much transformation that it turns it into pure noise. That is the forward pass. In the reverse pass, it takes this pure noise, okay, and then tries to do the different sets of transformation so that it gets this image back. So idea is to get the image back. Now how well it is happening, that will be defining the loss function, and the model will supposed to converge when it's able to kind of give very good approximation of this image. Now while doing this task, model learns how to create those images, right? So these diffusion models are very much useful in creating the images and different styles. And it has a lot of application in the like restoring the old photographs graphs. You might have seen a lot of videos, right, where we take a new song and superimpose on the old videos. So those all things done using diffusion model, because it has learned how to take something and destroy, and then from that destroyed version it is able to know how to create the image. So it is very important model, right? And used in like a lot of good practical application we have here. You can think of this like you take random noise finally, right? You take random noise, and then from the random noise you create a beautiful images. Start with the random noise and remove step by step, create the image. So this is like finally this is the application part. While training, we have to go through both the process: forward pass and reverse path, through which it is able to learn how to do that. Now coming to this flow model, these are like mathematician of our generative AI. They are mathematician. mathematician. What they do is they take, again, very basic do, and they apply a lot of mathematical steps. Okay, and if every step is reversible, reversible function and irreversible function. For example, let's say, if you think division, right? So multiplication, division and multiplication, they are reverse function of each other, right? So let's say if I multiply x with 2 and we get y, then if I divide y by 2, we get x. So every transformation should be reversible, and by doing that, it takes a base thing and creates a detail image. So opposite here, forward pass is opposite here. What we seen in the diffusion, the forward pass, we take a proper image and convert into white noise. Here we take a base thing and then it converts into detail image. Now reverse path, what happens is, we'll try to recreate this base. Now it will take whatever I have created here and apply reverse of these steps. So no, okay, basically this will be reverse of this, right? Because it should have to be in reverse sequence, and this is the reverse of this. Now we will compare, are we able to get this what we had here, and this will be the part of my loss function, which will I will try to optimize. And once model converts, it will able to kind of take this, get this, right? It will become expert in doing that. Now see here, it is like, clear sense of what is typical. It's like reversible kitchen recipe. Each step transform integration in a way you can previously undo. So this model is used where we require good precision, and it used for anomaly detection. And these all words we'll discuss. These are the, again, very mathematical thing which we'll discuss when we go through flow model in details. So basically, this is how you can actually make a mental model of it. So basically, you take very precise mathematical functions, apply that on base image, and create a beautiful image here. Now, coming to our last um, type of generative AI called VAE, Variable Autoencoder. Now, this is very much famous. This was one of the most famous model before this LLM boom happened. Now, this is what happens. Now, instead of forward and backward, we call this encoding and decoding. So, encoding, again, you see, it take the original image, compress this, and create a compact sketch. Okay. So it's like taking this image and removing all unnecessary thing, and just getting very compact sketch, or maybe steps also, which capture the essence of this. For example, let's say a dog comes in your comes in front of your eyes. You will see, okay, how this ears look like, how the nose structure is, how the mouth looks like, right? And based upon that, you don't go through, like, each uh, pixel, or like very 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 details of how ears, right? Each and every inch of ear looks like. You create this mental model. For example, let's say somebody says draw a face, human face, you will do something like this, right? So what are these are like mental model. It doesn't, you have not actually thinking much in depth, like, what is happening here. You are just trying to summarize or create a essence of that thing. That's what happening in the encoding part, right? So we create a compact mental model here. Now what happens in decoding is, you take this mental model, right? Like, as for example, in our mind we have mental model how a human face looks like. Now, every time somebody tells you to draw a human face, there will be some difference, right? But your mental model is same. Mental model actually is same, right? How human face looks like. But then, every time you draw, because of law of nature, there will be some randomness, gets added to this. That's called white noise. very famous word called white noise gets added in the thing, and then every time you generate a new image. So that is the idea of VAI. So you train this model with a lot of example, through which model creates a mental model of how this thing looks like, and then when you want to generate new, you it creates a sample out of this compact thing, and then when while doing that, some random noise gets added, so that every image looks very different, but the concept is the same. Now there are a lot of fancy stuff here, something called latent space. So basically this is called latent space, where you are learning the mental model. Now interpolation is the one where you, because this is same, right? Mental model is same, but every time you generate the new image, how? Because interpolation is different. Encoding decoding we understand, this will understand, we go deeper into VI. So this is the idea here. Now you can think about this, right? You take a lot of data and compress this. You take a lot of data and compress this, and when somebody want you to create a new art, you basically take from this skewed mental model and you construct something very new and novel. So thanks guys again to join me, and for joining me and supporting me. I hope you will subscribe to this channel, which will help me create some more content and interesting content like this. Thanks for your time.